Koto. In this video lesson, we're going to go over the two-way table pātai around having dinner in a restaurant. Okay, so calculate the probability that a patron ate soup. Well, let's find the row. Let's find the column that involves soup. There we have it. So this entire row are those that ate soup. There were 180 that ate soup out of a total of 297. That is the probability that they ate soup. And if you wanted to divide that and give it as a 4 decimal proportion, 0.6061, but you're welcome to leave it as 180 over 297. Next, calculate the probability that a patron ate soup and fish. So if this row is the soup and this column is the fish, where do they intersect? Exactly. Onotoko ma rima. So 65 out of 297, that's the proportion that ate soup and fish. Next, calculate the percentage of people who ate mussels or fish. So there, we want to find the intersection of both of those. So if they ate mussels, that is this row. There were 117 out of 297 that ate mussels. And those that ate fish is this column. The only thing you want to look at here, as this is now a merit level question, there is one intersection here, the 67, that ate fish and mussels. You can't count them twice. That's why we only added on this 65 out of 297 to give us 182 over 297, or 0.6128. Now this one does ask for a percentage. So we've got to times that by 100, and 61.28%. Next, calculate the proportion of steak eaters who selected mussels as a starter. So we're only looking at the steak eaters. That means this column right here of steak eaters, that's all we're looking at. Now, how many of those had mussels as their starter? Well, there's going to be the 31 out of 94. Again, when it says of steak eaters, you can only look at that column of steak eaters. If you went over to the right, they ate fish. Over again, those are vegetarians. So only looking at that column. Next one, calculate the proportion of those who chose the fish who had the mussels to start with. So now we're only looking at the column that includes the fish eaters. And how many of these had mussels as their starter? That would be this 67 over 132. And changing it to a decimal by dividing 0.5076. Next one, compare my last two answers. Well, we can see when we change the fractions to decimals, it's easier to see which one is bigger. Looking at 31 over 94 and 67 over 132, you might not be able to see which one is bigger. But by changing it to a decimal, I can clearly see which one is bigger. Now, I did have these numbers upside down. Whoopsie. It should be 67 over 132 divided by 31 over 94. It gives us 1.539, meaning those who chose fish they were 1.539 times more likely to choose mussels to start with compared to the steak eaters. Next, calculate the proportion of patrons who ate no seafood in their meal. Well, which of these are no seafood at all? Well, that's steak, and that's mussels. That would be seafood. So we got 63 out of 297. Fish would definitely not be vegetarian, and this vegetarian is 52 out of 297. So those would be the two you would add up. 63 plus 52 over 297 is 115 over 297, and that's 0.3872. Lastly, car rally being held. Chef estimates they're going to sell about 400 meals. Estimate the number of steaks. Well, first we need the probability of getting a steak. The probability of steak would be 94 out of 297, right here. That's 0.3165. Times that by the total number of meals, I get 126.6. I'm going to round that to 130. Chef should order 130 steaks because it's best to have a few extra. Hope that was helpful. Please send any pātai my way. Mauri mahi, mauri ora, ka kite anō.